All right, so this go around, we're looking at the graph of y equals log of x minus 5. So, of course, this is a transformation from the graph of just plain old y equals log x. And we can look at this and say, it's an outside change. We are doing, and it's a plus minus, so we are doing a vertical shift down by 5. All right, so if we look and we graph plain y equals log of x, we know it's going to have an x-intercept at 1, 0, right? Log of 1, anything 10 to the 0 power will be 1, right? Then we have log base 10 of 10 would be 1, so we get a point going right on there. This is a very slow growing graph. All right, so see if I can sketch it here. Not a very good sketch, but you get the idea. So for our transformed function, we're going to be taking this thing down 5, right? So is our domain going to change? No, it's not, because we're just going to take this function. We're going to say, okay, instead of 1, 0, we're going to have 1, negative 5. Instead of 10, 1, we're going to have 10, negative 4. And this graph is just going to have been moved down 5 units, and that's a little bit better. That is not a horizontal asymptote there. It is just a very slow growing graph. Our range here is still all real numbers, so negative infinity to infinity. And our asymptote has, if you move a vertical line up or down, it doesn't change, right? So this will still be x equals 0. So let's take a quick look at that in GeoGebra. Let's see here, there we are. So if we do y equals log of x, so we can kind of see here, it's really slow growing. And if we do y equals log of x minus 5, we just shifted the whole thing down 5. So that's pretty much a lot like what our graph looks like. So we've got time for a second one here. This one is going to be versus the natural log function. Okay, so our basic log function is going to be y equals ln x. And so hopefully you look at this and you say, I've changed x to x minus 3, so that is going right 3, right? So that's a horizontal shift to the right by 3 units. And then we are going, let's see, up 2. So we're going to do this as 2 shifts. We're going to follow PEMDAS. All right, we're going to put that down here, PEMDAS. Okay, so first we're going to draw our y equals ln x. We know it'll go through 1, 0, right? Ln of 1 equals 0 because e to the 0 is 1. Ln of about 3.21 is 1. Sorry, 2.71. I don't know what I was saying. So our original ln of x graph, just roughly speaking here, because I don't know there are any other points on here, we're just going to draw kind of like that. So please excuse me, dear Aunt Sally. So we are going to do the parentheses, the change in x to x minus 3 first. We're going to change that color to red. So this is going to shift over 3. So instead of 1, 0, we're going to have 4, 0. And instead of 2.7, comma 1, we're going to have, let's see, 5.7. Right? Oh, we're still shifting over. Yeah, 5.7. So here. So it's going to be about here. Right. So we're going to do that. Now, but our asymptote, which was the x-axis, will have shifted right by 3 also. So instead of being x equals 0, we're going to have an asymptote at x equals 3. So I'm going to make sure I don't cross that. There we go. So this one is, so the red one is y equals ln x minus 3. The blue one is y equals ln x. And then we're going to do our last transform, we're going to take that and shift up 2. So we're going to take the 0 and bump it up 2. We're going to take the 5.7 comma 1 and bump that up 2. Does that change the x-axis, the asymptote? No. So we will still be at x equals 3. Our range is not being affected, but our domain was changed when we shifted over to the right. So we're at 3 comma infinity. And we're going to put our sketch our graph in here. There we go. Close enough. Right, so our green one here, y equals ln x minus 3 plus 2. All right, so don't make these harder. Just work them just like you did in chapter 3 and in chapter 5. All right, so we've got a little bit to go, another couple of examples, and we'll be done with this section.